Hey, welcome back. And it is the start of Module 2. So, Module 2, we're going to begin off talking about systems of equations, more specifically, systems of linear equations. So, everything that we just did from the previous module when we talked about linear functions and being able to graph and things like that, we're going to wrap that right back up into this. But before we begin with solving systems, we need to refresh our minds about, well, what does it mean to be a system of equations, or specifically for us, a linear system of equations? Okay. So, a system of equations, here's kind of the bare bones definition of it. It is a set of two or more equations that we want to solve. Okay, a set of two or more equations that we want to solve. And the equations, the ones we're going to be dealing with, they're going to be linear, and we're really going to only mess around with two. But as you progress into college algebra and beyond, there can be more than one system. And they don't have to be linear, as you will find out when you hit up college algebra. Okay. Show you an example of what a linear system looks like and what we're going to be dealing with. Here they are. So I've given you two equations. One of them is in standard form, which is the 3x plus 6y equal to 12. And one of them is in slope-intercept form, which is, the y equal to 2x minus 3. And so this is what our systems are going to look like. And again, they're going to be linear in nature. So we're going to try and keep it as low as what these systems can be. Okay. So everything that we're dealing with, these are, keep in mind, linear, which means that they are lines. Okay. So that's the basic definition of a system. There's what a system looks like. So let's continue talking. There are three ways we solve systems. Okay. In class, I would always ask you guys what those are because most of the time you remember them all. Okay. So there are three ways, and we're going to be learning all three ways. So the first method is graphing. Okay. So you can solve systems by graphing. It's not always the greatest because graphing is very, very tedious and not all the answers always come out nice and neat. So graphing, it's an okay method. Okay. And especially when it comes to word problems, graphing is not the greatest method because real world problems are often very messy and sometimes deal with extremely large numbers or extremely small numbers. So graphing is not the greatest method when it comes to, definitely when we look at those real world problems, those word problems, okay, which we will get to. After that, there are two other methods, and these are pure algebraic methods, okay? The next one is what we call elimination. That's what we will learn second. We will learn how to solve systems by doing elimination. Sometimes the book or the textbook might call this the addition method, and you'll see that when we get to elimination. So sometimes it goes by the addition method. And then last but not least, substitution. Substitution, where we take one equation and we substitute it into the other to help us solve. Okay. Elimination and substitution, these are the methods that come in handy for us when graphing is just, out of hand and, not the greatest method. Okay. Especially like word problems or real world problems. That's where we want to use elimination and substitution. And again, I'm going to teach you all three of these. And once I teach you all three of these, I don't really care what the directions say when you go through and solve systems. If you like graphing and you want to graph the whole way, you graph the whole way. If you like elimination and you want to use elimination the entire time, use elimination. You do you, boo. Okay? So, no matter what those directions say, again, this is all on computer. Is the computer going to know if you're doing elimination? No. Is the computer going to know if you're doing substitution? No. Okay. Even though the directions might say, hey, do substitution, okay. Computer ain't going to know one way or another which method you use. Okay. And neither will I, and neither do I care. As long as you can get to the answer, this is why we have 3 different methods, because some people like to do one method over the other. So you choose the method you like. You do you, boo. Okay? It's not going to hurt my feelings. And I'm not going to take points away just because you didn't do it the method that they asked you to do it. But I will tell you, generally, whatever method they want you to use, that's generally the best method for it. Okay? Kind of a rule of thumb. So if it says graph, then graphing's probably the easiest way to get it through that problem. If it says use elimination, then elimination's probably the way to go because that should be the easiest method. Just food for thought. All right, so let's talk about what happens when we solve. So when we solve, there are 3 types of solutions you're going to get. 3 types of solutions. Okay, so you should be able to look at a graph or look at equations and actually know what's going to happen. Okay, so one of the types of solutions you will have is what we call one solution. When you have one solution, that means graphically the 2 lines intersect each other. They hit each other at a point. Okay, solving systems when they are linear, if there is a solution, it will always be one point. Systems cannot intersect, when they're linear, cannot intersect each other twice. It's impossible. They're lines. Lines are straight. They do not bend back around. Okay? So a one solution answer means that on the graph, the 2 lines intersect somehow, some way, some shape, some form. If you're looking at the equations, if they're in slope-intercept, they will have different slopes and different y-intercepts. Okay? So if you have 2 equations, they will have different slopes and different y-intercepts when looking at them in slope-intercept. Okay? So one solution means that you have a point, parenthesis x comma y. Graphically, they intersect at one point. Equation-wise, there are 2 different slopes and 2 different y-intercepts, generally. All right, the next type of solution is what we call an infinite solution. Okay? Infinite solution, basically it's just the infinity sign. It's kind of like a sideways 8. Graphically, it looks like a singular line. Okay? And the reason why it looks like a singular line is because both lines are graphed on top of each other. So how many times do they intersect? Infinitely many times. Because both lines are the same. Equation-wise, they should be the same equation. If they're in slope-intercept, the slopes and the y-intercept are the same because they are the exact same line. They are the exact same equation. Okay? So, infinite solutions, sideways 8, the infinity sign, which we've seen before. Graphically, it looks like one line, and the slopes and the y-intercept are the same. Okay, equation-wise, because they're the exact same equation. Last but not least is the no solution. So the circle with the line through it, no solution. Graphically, the lines are parallel. So they're 2 lines that do not intersect each other. Hence, no solution. Because if you can't hit each other, there's no answer then. Okay? Equations, the slopes are the same, but the y-intercepts are different. So, and that makes sense. Remember, we talked about parallel lines before. Lines that are parallel have the same slope. So that makes sense here that the equations have the same slope. Just the y-intercepts are different. Okay? So no solutions, circle with a line through it. The lines are parallel when they are graphed. They do not intersect. And equation-wise, the slopes are the same and the y-intercepts are different. All right. So those are the three types of solutions. There are no other types for linear systems of equations. There's either a one solution where they graphically they intersect once, equation wise, different slopes, different y-intercepts. Infinite solutions, so sideways 8, graphically they are the same line because they have the same equation, the same slopes and the same y-intercept. Or your answer is a no solution. Graphically, they are parallel lines, they do not intersect, and the equations have the same slope but different y-intercepts. Okay? So that is the general idea behind systems of linear equations. I got one more problem right here. So if I have a system like 2x plus 3y equal to 11, and negative 5x plus 7y equal to negative 3, how do I know if 0, 4 is a solution? Plug it in. Absolutely. All you got to do is plug that in. If 0, 4 is a solution to this, because that's a point where the 0 is the x value, the 4 is the y value. In order for this to be a solution, all you're going to do is plug it into both equations. And as long as it is true for both equations, then it's a solution. It has to be true in both of them. Not just one, but both of them for it to be a solution. So go ahead, pause the video, plug in the point to these, and see if it's a solution. And that will end the introduction to linear systems. Go. Okay. So we're going to plug into the 2x plus 3y equal to 11 first. So 2, parenthesis, I see x. X is 0. Close the parenthesis, plus 3. Oh, I see y. So parenthesis 4, parenthesis, because the 4 is the y value, equal to 11. So 2 times 0 is 0, plus 3 times 4 is 12, equal to 11. 0 plus 12 is 12. Does 12 equal 11? And the answer is no. So this is not a solution. You don't have to check the second one. The moment it doesn't work in one of them, you're done. So since this did not work in the first equation, this cannot be a solution because it has to be true in both of them. And this is not true. Again, if you have 12 tacos and I have 11, we're not the same. You got more tacos than me, jerk. All right, I think I might have one more. Let me check. I do. Go ahead and pause the video and give this one a shot where your equations are x plus 2y equal to 4, 5x plus 10y equal to 20, and I want to know, is the point 2, 1 a solution? Go. All right, so the 2 is your x, the 1 is your y. So let's plug in. So it's x, so x is 2, plus 2, oh, I see y, so that's parenthesis 1, parenthesis, equal to 4. Now we do a little quick solving. So 2, or not solving, but PEMDAS, 2 times 1 is 2. So 2 plus 2, does that equal 4? And absolutely. 4 equals 4. So far, it checks out. So far, 2, 1 as a point is a solution. Well, all we have to do now is check the other one. You have to check both of them. So we got 5. Oh, I see x, so that's parenthesis 2, parenthesis, plus 10. Oh, I see y, so that's parenthesis 1, parenthesis, equal to 20. Do some PEMDAS. 5 times 2 is 10, plus 10 times 1 is 10. So is 10 plus 10 20? Absolutely. 20 equals 20. So that checks out. So is this a solution? Absolutely. Yes, because it is true for both of them. So 2 comma 1, the point is a solution. Okay? So I just want to show you your assignment. That is it for the introduction. So you can see on your assignment here, one of the questions is determine which of the graphs of a system of linear equations has no solution. We talked about that. The second and the third question are just like that. Okay? So the second one is saying which one has the infinite points of intersection. And then the third one is which one has a solution of 1 comma negative 6. And then down below, it's going to ask you some questions like in number 4. So it says the ordered pair is a solution for the first equation. Why is this not enough to determine if the ordered pair is a solution for the system? And again, we talked about that. So kind of look at those answers. You should be able to answer this now. And then down below, here I'm giving you a system. Okay, and without graphing, I want to know, is it going to have one solution, no solution, or infinite solutions? That's where we talked about what it looks like at the equation. So look at those slopes and look at those y-intercepts. Same thing on number 6. Look at the slopes and look at the y-intercepts, but be careful. Number 6 is written in standard form, so be careful. Then the last 2 questions. Why can't a system of 2 linear equations have 2 solutions? I talked about that earlier. And then the last one, is that point a solution? See, you got this. Everything on this assignment we talked about in the video. So I wish you good luck, and I will see you next time.